And next up on our conversation, the Allam cycle. You know what the Allam cycle is? I didn't, but I heard the term and I said, tell me more about that. What the heck does that mean? And then I learned a little bit about it and I said, wow, this is fascinating. This is interesting. This is innovative. And because it'll surprise no one, the Energy and Environmental Research Center is right in the middle of it. And we're going to talk a little bit about that today on the program we call Energy Matters. Jason Laumb is here. Jason is a Senior Research Manager at the Energy and Environmental Research Center in Grand Forks. How are you doing, Jason?
Hey, I'm doing great, Scott. How are you doing this afternoon?
Doing good, thank you. So tell folks what the Allam cycle is.
Well, the Allam cycle, it's not a two-wheel mode of transportation. It's not a bicycle. It's a physical power cycle. So it's a little bit of a different twist on creating energy. When we think about the way that we create energy right now with our standard coal-fired power generation facilities, we boil a lot of water. And it's very inefficient to be boiling water. You lose a little bit of energy every time you go through a phase change. What the Allam cycle does, instead of using steam to drive a turbine, it uses CO2, a product of combustion from when you burn a fossil fuel like coal or like natural gas, and it uses that carbon dioxide in a state that's called a supercritical state. What that is it's not a solid, it's not a liquid, it's not a gas. It's in a supercritical state where it behaves more like a liquid, and you don't have to go through that phase change. You don't have to lose all that energy. It's at a high pressure, and that CO2 is then used to drive that turbine.
So the net result, the end result, then is a more efficient way to do what we do now, which is pretty efficient given the affordable, reliable nature of cold electricity. But you're making that process even more efficient, right?
That's exactly right, Scott. You're making that process more efficient, and not only making it more efficient, but you're reducing the emissions. A Allam cycle fired or a coal-fired Allam cycle plant really isn't going to have anything coming out of it except for a stream of carbon dioxide that's ready, to be used for enhanced oil recovery opportunities, to produce more oil out of some of our legacy oil fields in North Dakota. So it's not just a way to do something more efficiently, but it also has a solution for carbon dioxide integrated into it. And as we look at political winds changing and things happening around carbon dioxide, for those folks that have coal-fired assets or even those that have natural gas-fired assets, it becomes very important for future power cycles to have that in the back of your mind.
Yeah, imagine that. The critics would have nothing to bark about. I mean, the folks that have been trying to shut down this industry for environmental reasons, it goes away with this technology, which is why you should let technology just play out in these areas. I mean, even if you look at the progress through the investment of technology in the current operations of coal-fired electricity, it's getting better all the time. And this is another neat idea on the shelf. So it's pretty amazing that would happen. So is this something you build a prototype of? How do you show everybody this is the way to go?
So this is a cycle that we've been helping with for about the last 2 to 3 years. The technology owner is Eight Rivers Capital, that owns the technology for the cycle. We've had strong support from the state of North Dakota through the North Dakota Industrial Commission program, also supported through Elite Clean Energy, BNI Coal, the Lignite Energy Council, Dakota Gasification, Basin Electric. So we not only have the state putting funding resources towards this, but we also have key corporate partners within the state of North Dakota that could be potential end users of this technology supporting the work. Now, we've gone through several years' worth of work here where we've looked at what do we need to do to make this technology work with coal. The folks at Eight Rivers Capital right now have a large demonstration plant down in LaPorte, Texas. It's around 25 megawatts electric that's natural gas fired, and that unit came online in May. So far, they're kicking the tires on that. They They had their first fire, and it's not a bad thing. First fire is a good thing when you're talking about a new combustion plant. And things are moving forward there. And what we're doing right now is we're looking at putting things together for demonstrating this technology with coal. Now that we've gone through some of the due diligence steps, and we know kind of what we need to do to make it work for coal. We have a project right now with the U.S. Department of Energy looking at potential pilots for this technology, for large pilots. How big would that pilot be? And when you're talking about energy generation technologies, a pilot is 20 to 50 megawatts. In this case, what would we do? Would we do a 5 megawatt type of demonstration? Would we do 50 megawatts? What would we do to show that next increment? And right now, that's what we're working on. We're working on how big would that demonstration plant be, that large pilot demo, and where would it go? Where would we demonstrate that? And we're right now narrowing that down in anticipation for some DOE funding opportunities coming up here later this spring.
So, ballpark figure, what are you talking before you have a prototype up, and from that point until this is sort of the new thing, once it's proven out, what kind of timeline is this on?
That's also a good question here. We're multiple years away. A lot depends on what happens down in the port with all of that combustion equipment that they're vetting down there. Everything's successful there, and we're successful at getting a large pilot of this, put up. You're still looking at 5 to 10 years down the road before this technology is something that you would go and you would start putting into the ground for new power generation. It's a exciting technology that has some promise. There's still a little bit of work to do yet to make certain that this is a viable technology for coal.
And of course, there's a little bonus in here. What Jason is describing as a giant sundae, but the cherry on top is this technology would allow for the capture of CO2, and then that could be used with the enhanced oil recovery efforts that EERC is also working on to improve our fortunes on the oil side, right, Jason?
Yeah, that's exactly right. That's kind of the cherry on top of the sundae, as you described it. That this technology creates that a very clean stream of CO2 as part of the process, and that is one of the challenges with retrofitting an existing plant with a CO2 capture technology. You pay a little bit more of a penalty. So we see that retrofitting an existing plant as being the near-term opportunity. This is an opportunity that's a few more years down the road, and the state is really looking at both, and also looking at the CO2 that is produced from these facilities, being able to utilize that and store that.
Yeah, so that's a game changer for both industries, really. Carbon capture obviously goes back to the your description of the benefits of what happens through the Allam cycle process being used, but in the oil industry, obviously, to have enhanced oil recovery using something that is, for lack of a better term, a problem that you're solving for somebody else, that'd be quite a win-win, wouldn't it?
It would absolutely be a win-win. You take something that, like carbon dioxide, that is currently causing you a lot of headaches, you turn it into a commodity. You turn it into a byproduct of your plant, and in some cases, it may be producing a large amount of revenue for your plant. Maybe you're selling electricity as a byproduct. It would be very interesting to get into that scenario. But you take something that once was a problem, and now you're getting paid for it. That's a big deal, and that kind of turns the economics on its head.
What is it ever? Fascinating conversation. Keep up the great work, Jason. Thanks for the update.
Alrighty, thanks a lot, Scott.
You bet. Jason Laumb, who is a Senior Research Manager at the Energy and Environmental Research Center on Energy Matters.